Alright, good morning everybody. It's a new day. I took a break last night and I woke up today and I sort of just banged out the rest of this cat. And I'm sure it goes to no surprise to you guys that it's much easier to work cat than working cat alone without speaking to a microphone. But it is. It's a lot easier. And I mean, I didn't really add too much, but all the sort of like little mistakes that you get tripped up on while designing something live, you can sort of work through a lot faster. But yeah, there's not much added. There are these plates, there are these spacers. I'm not really sure where I left off at, but I think it's a pretty logical progression. These six holes are supposed to be threaded, and like something I don't get, huh? Make cannot resolve make character. Weird. Just noticed. Well, the things throwing the errors are also. Oh my Jesus Christ. Okay, well, I'll ignore the errors for now. But sorry, got sidetracked a little bit. So you should fix all that later. But right now, the the biggest changes are that I have added in these spacers, I've inserted in the hex shafts, and there are appropriate dimensioned hex shaft spacers everywhere. That's mostly it. On the main plate, you'll see that I try to do this thing in non-shape where here I try to tap these 10 holes for a quarter 20. Maybe I did something wrong, but they do not show up as tapped. But you can go back to the assembly and you can sort of see how I'm planning on this working. Where one side isn't tapped, but it avoids using a nut on the back end. So um, these two holes aren't tapped, but these two are tapped. So it screws into the tubing like here, straight into the plate. These two, this hole and this hole, aren't tapped, and this hole and this hole are tapped. So it's screw it like that. Motor holes aren't tapped obviously because the pattern, and that's it. It's six holes. I think it all makes sense. All works out. What else did I have to say? So these two pulleys, I don't think this squishing is correct. I think there is more spacing between there, but it's as simple as just reducing the size of this spacer. There's still room for me to walk this way on this gear, so reduce the size of the spacer, give these pulleys more room to breathe. That should be fine. Whether or not they should be smack together like that instead of having a 0.1 inch shim in between them, I don't know, but they seem to have been running fine on our drivetrain this year and last year, just stacking together. Actually, last year we didn't stack pulleys like that, but this year we've been stacking pulleys, and maybe the 4 or 5 hours of practice we've gone has seemed to run fine. Maybe it's been a source of issues. I don't know if it does turn out to be a source of issues. Again, we have some, we do have some room here to walk the gear back, and it's not a super big deal for the protrusion on this gear to be touching the protrusion on this pulley. We could actually move this spacer out here. I think that's like the only. This is like the only. It's like it was very simple assembly, so to speak. Hex shafts, they're all like the right size. I'm pretty sure. The nice thing is that there's no need for collars or anything. It's pretty cool because if you just make spacers to the right lengths, you constrain the shaft in between the two flanges of the bearings, and the yeah, constrain the shaft. But you do still need to put like a bolt in a washer or like an E-clip. This is actually a problem. I think we might have to address that. Don't know how to, because I don't know how you get a bolt and a washer there, or like a there. Um, and maybe I'll fix that off screen. That's not tenable. You can't do that. Maybe what I'll do instead is that what I could do is, you know, reduce the size of the spacer, put in a collar, and that would restrain the shaft. I wouldn't put a clip here. I'd put a clip like here. That makes sense. Here it's not an issue. I can put a bolt and washer here, and bolt and washer here. It's kind of a trick that I learned when I first started doing CAD. That constraining hex shaft is kind of a pain. And non-shape it seems to be pretty good actually, but I know in Inventor, constraining hex shaft is kind of a pain. So I mean, it's really simple, and Thunder Hex comes like this. Even though we don't use Thunder Hex, it's really simple to just extrude out your hex shaft with a hole in it, and lining it with that center hole makes every constraint and mate really easy. So I guess if you're using other CAD software and trying to make hex shaft constraints work, that. So this really bothers me. I want to just like close that off like there. I think that's what's next for me. I'm gonna do that on this. This also, like, I mean, it bothers me to a smaller extent because like an end mill can like excavate this material, and like I mean it couldn't really do this. Like it cannot excavate this. I'm pretty sure like a quarter-inch end mill cannot make that profile. Obviously, it does not have a a elliptical kind of orbit. But yeah, I'm gonna do that. And then I think at this point we can go over to the main assembly. So I think a lot of you are probably wondering, like, like this doesn't really look that like space efficient. There's a ton of negative space here, a ton of negative space here. Like, like, is there really any, like, have you really made any improvements? Have you just like take a step forward and take 2 steps backwards? And because that's how I was feeling at first. It's like, man, all this work was for nothing. But then looking at this gearbox in place, compare it to old one. Like first, like make a note of how much space is in between the gearboxes right now, and then let's look at the drivetrain as is. Like, so again, my point before like these motors being up top means like it's fine because like all this space was being used up by like, the gearbox before, so it should make no difference. But look at the space comparison. Like it's pretty cramped in here. Like we can measure this. So let's see from like the edge of one talon, the edge of the other talon. There's like 5 inches. Yeah, 4.7 inches. And then from this pancake piston to the other pancake piston, and there maybe 6.1 inches. Just about. So I mean, let's go look at. We can go measure this for the other gearbox. But like, I don't know. It looks pretty solid to me. Like I feel like there's an immediate performance improvement in terms of just like space made available. So like let's measure this. So this is compared to 4.7. We have 7.1 inches. So there's a 2.5 inch increase in space here. And if you remember, there's our whole climber assembly goes in between here. So the climber assembly was like, it wasn't going to touch the motors at any point, but now there's just more breathing space for every single mechanism lying underneath our superstructure, which is good. Like we want that. And now this is compared to 7.2, and now it's 13.5 inches. So that's over 6 inches of space now in between the lower parts of the gearbox. This is actually good because now, excluding out this gearbox, you can run a belly pan all the way through, and it's kind of stupid because we to accommodate these chonking gearboxes, we had to make 2 component belly pans, but you could have just extended it out all the way with a gap here. So honestly, I'm not even sure how viable it is, because then there's still going to be like a big cutout this way. Maybe even then a belly pan wouldn't be the smartest idea. Like, even looking at it, I'm not super satisfied with it because again, there's a ton of space used up here that's not really needed, and like all this negative space that just like it makes, like, if you look at this, like putting this together is going to be like a charm, like a dream. These bolts are super accessible, and then you rotate the wheel, I guess, but yeah, if you rotate the wheel a little bit, it's kind of easy to get to, like, yeah. So the hole is accessible through this. So you rotate this wheel a little bit, and then you can get right into this other motor gearbox. You actually, without even taking off the wheel, you can take off the motor now, which is like really accessible. And like that's a sacrifice we make, putting in a lot of space and less weight in the gearbox. But then now these motors are like accessible through where we see. So now there's no need to take off the gearbox, ruin the Loctite. They're just like in place. You can just loosen and tighten. And I mean, with these wheels, these bolts are really easy to take apart. But I think we switched to the Andy Mark Performance wheels, so like the aluminum extrusion wheels. I think they also have the same 6-spoke pattern that makes these holes accessible, and so that's like really good because now you can take off the entire gearbox without ever having to take off the wheel. Which is, I think that's pretty cool. Pretty cool. So instead, check shaft properly dimensioned. I'm happy about that. And I think, besides, like, so we came in here with 2 demands, that it was more accessible and more serviceable, and also that it didn't loosen up all the time. We addressed the accessibility. I'm really happy with that. And sort of the next big thing is the vibrations. And I think if this huge plate attached to the side of this tubing, and probably 4 bolts going in this way, it's definitely going to be much more held in. And just by nature, there's less of a vibration. There's less of a gearbox to even like vibrate up and down. Like there's less gearbox, and it weighs less, so it's not going to exert as much of a lever force on the bolts holding them in. Plus, there are a few more things going for us here. Here, the bolt going in from the tubing goes all the way through the other end of the gearbox plate, so it holds everything together. And that we see that in 2 places, and then you have 2 bolts that just connect the plate to the gearbox. I mean the plate to the tubing. I mean, I think that is pretty solid. You put some Loctite in there, and then you call it a day. But there are other ways to increase this this rigidity. Like, I think in the real drivetrain, we can like, obviously these wheels are spaced out more because otherwise these nuts would collide with the tubing. So I'm pretty sure these are spaced out. Actually a pretty fair amount. And because we're using the AndyMark performance wheels, it's actually there's a taper going in from the external rim down to center bore. So actually there's space for like a bolt head peeking out of here. So what we could do is you could you put in a spacer to connect between the walls of the tubing, and then you put the bolt through that as well. So that way you get longer bolts, and then you really increase the rigidity of the gearbox because you're constraining between this plate, spacer, the plate, this wall of the tubing, a spacer, and another wall of the tubing. So very rigid. That's not in effect, but like that is a change that we could make to make it even more rigid if we continue to see the vibration happening. What else is there? There's not really much else. I think if it turned out that maybe this gearbox was like uh, rigid enough, or for a reason, yeah, for a reason not rigid enough, there are a few places we could put holes. Um, I would say, number one being there's a hole here that you can line onto and connect the gearbox to the tubing. If it's not rigid here, there's a hole here to connect the tubing. So yeah, and it doesn't quite clear. It doesn't quite clear the tubing here. Like you can't really fit a bolt in there. It's my bad. But you can put a set screw in there. Actually, really, you could put like a set screw in here, and like a spacer cap at the ends, hold the gearbox like that, and that wouldn't really be doing anything. It would just be at that point like a spaced out member. It wouldn't be really doing much for structural rigidity, but it would just be like hanging out in there. So I think we're kind of committed to these four. Oh, whoops. These four mounting points as like your go-tos. That's like this is how the gearbox is held together, and it's not like if this is bad, it's not gonna work. Like it's like this is these 4 points are structurally integral to the gearbox, and if they turn out to not be good enough, then like we're kind of SOL. And if that happens to be the case, then then that sucks. Like there aren't really other more convenient places. Like, and that like that's okay. Like we can make holes work. We can redesign to have there be a hole here, put a spacer across like that, but there aren't for now. And I think we'll be fine. I mean, this is still all like a theoretical thing. Like I'm speaking as if this is a real thing, but it's not. Speaking more, I know that the belts do not look right. That's because they are probably like so. Probably my finest achievement is like figuring out how to get perfect looking belts on pulleys, and I showed the twins how to do that as well. Bracement injury. I really appreciate you trying your best. And you don't like it's at this point completely aesthetic, so really there's no need to even be like sad that it doesn't look right. But they don't look right. But rest assured, the distances are correct. These belts are like super nominal. They're not really like um representative of real life, even though like they kind of do look like they're in real life. You can kind of see the center drop, right? Can you really see the center drop? No, you can't really see the center drop. But there is a center drop, and I think that's what's causing a lot of like the weird looking issues. Probably the next thing to note is that we see how the belts uh, clip the pulley. It just means that we need to remake these shafts so that everything gets spaced out, like a quarter of an inch plate. Yeah, so not too many changes needed. I am worried about the true drop-in um, nature of this. Like I think so. So a robot's not a robot isn't symmetrical. It's its COM is like pretty centered, but it's got different things in different places. It's not like left right. There's no left right symmetry, and there's definitely no front back symmetry. Um, so I think on the left side, so this is the robot's left side. We're totally this is like a true drop in. But on the right side, I'm pretty worried because what's going on this right side is that there's a cable run on a 1/8 inch thick 1 inch wide strip of aluminum going from around here all the way to the back of the robot. So because our robot, go back to popcorn. It's not visible here, but this entire I can't do it. All right, well, this entire robot hinges up, so it it goes up, and you have to if you're going to wire your shooter or wire the serializer, you have to be able to have cables that extend all the way up. Either they are on like an IGUS chain or whatever, or they come out from the back into all the other uh, motors. The reason why you want them coming out from the back is so that when they hinge up, you don't need to increase travel length or anything. They just rotate, pivot, however. So what we have is we have a giant like bundle of cables coming out from this back corner, going out to our serializer motor here, our intake going all the way over here, and the three motors on our shooter. 1, 2, 3. Uh, you know, going over popcorn makes me feel like I should go through I should have like a robot rundown video coming up, but that's for the future. So there's a huge cable run going all the way over here, but we go back to the drivetrain. That cable run is connected to uh, again not visible here, but our entire belly pan PDP Roborio system over here. God, it's kind of frustrating. Where did they put this? Okay, here it is. So, completely blocked out to me, but there's a I think PDP here, battery, Roborio, and VRM and PCM. Yeah, okay, that looks right. So we've got to run wire from here along the underside of the robot and through this open slot to everywhere robot. So there's like bottom side, top side, and running power in between the bottom side and top side becomes pretty difficult. It was like our biggest challenge in like week 9. Thinking about it, we're very lucky that we had a week 9 to be working on this because God, we were so behind schedule. So going back to the custom gearbox, so back on the right side, there's a cable run going from here to here and through this back hole. So, like, if I can show you, there's okay. This is not true. What? It's ever so slightly tilted. Okay. All right, whatever. Either way, I'm pretty sure this is like, yeah, this is. I don't have an 1/8 inch of clearance between the top and the bottom of this 1x1 tubing and this gearbox plate, and there's an 1/8 inch plate coming from here to here, on which all our cables are routed. And what does that mean? I think that means that if we switch this gearbox spacer to 3/8 of an inch, that plate would actually then fit. Also, it's a thin enough plate where if we just bent it over this spacer, that would work. But no, we're not gonna do that. Let's just replace these spacers with 3-inch spacers, and that plate suddenly fits. Um, Reason why I'm worried that might not work is because if I recall, like on that one cable guide plate, there's like a bunch of stuff on the top and the bottom of that plate, so I feel like it's gonna get in the way of these spacers, and that's not good. Um, so it's not a so even though like if you replace these with spacers with smaller spacers, it would be much closer to a true drop-in replacement. I think there's still like unforeseen things. Like on 2Train we don't CAD everything in the robot and then manufacture it. A lot of things going from like across Bob, yeah, mostly coming from Bob's drawing board lab, and my work in Inventor, and sort of the twins work on the drivetrain and the intake. It sort of all gets put together, and only now, right before our season got cut short early, are we starting to like put it all together and on shape. So a lot of things aren't really fully modeled in here, which is um, bad because then we can't figure everything out. But it's just a byproduct of how the team works. We don't have a universal CAD system, and having a universal CAD system would be good, but I think there are certain workflows set up that allow Bob to work faster and me to work most efficiently, or this is what the twins started working with. So I think it's everyone's comfortable with what they're working in, and we sort of make it work. And Popper's not a bad robot. Like it definitely came together really well. And I think sometimes how it came together is that we sort of just like we allotted space for every mechanism. Like we in like on paper and pen and like in our minds and all our conference talks, we planned out how this robot had to work, and sort of every designer took what they what they knew and made their designs work in the space they were allotted. And yeah, and if you adhere to that rule strictly, but you don't adhere to the same CAD rule strictly, you still end up with a very good robot product. So I'm not mad about it, but it is now where we have to like the true strength of CAD comes in with like modularity and being able to take out a part and know exactly everything around it, so you know what it's going to hit. Right now, I'm just working off memory, and because it's only been maybe 2 weeks since I last worked with the robot, so I know what everything kind of looks like. But if you ask me a month from now or 2 months from now, if I could tell you where everything is on the robot, I couldn't tell you. So that's like the biggest problem I see. But in every other regard, like I think that this gearbox is a straight up improvement. This gearbox, and when I look at it, I feel like the changes we made to it to make it work for our system just almost rendered it really unusable. This like the vibration I feel on these two, like the forcing surge on these four spacers, I feel like was so much that I don't know how we expect it to not vibrate seriously. Oh, you kind of see here how our piston is mounted over here is kind of hidden, but which actuates our whole intake up and down. I'm not a fan of this intake piston mounting either. I mean, it looks really, really cool to not see a piston here and to still watch it go up and down, and that's super cool. But we sheared off the entire triangle portion here on this slot here. You kept slamming into this. And I think we needed more like mechanically advantageous place to mount the pistons like above ground to this higher point. But we've made it work. We've added foam padding. We've thickened up this triangular portion, and we've extended out this. But not a problem. And so this piston, as modeled, it looks like it gets in the way, but it doesn't. It actually the piston runs. I think. Oh geez, maybe it does run. I think. Oh damn. No, it does not, because it's like way shifted out over there. So I think the piston runs directly over this 1-inch channel, 1-inch tubing. Yeah, I buy that. It runs over this 1-inch tubing. Plus, it's kind of above the gearbox. It's if you look here, it's mounted up around here above the gearbox, and we can kind of see that it's close. Like, I'm not gonna say that we're for sure clear of it, but the piston mounts around here, like floating above this gearbox, and it pivots right next to it. And the lowest point, so I think we're pretty clear. Like, it mostly dips down to close to to here, like on this diagonal line is where the piston is kind of resting, and then it kind of extends up to be resting flat. So I don't think you have to worry about it clipping the gearbox plate. I think it's going to be above the gearbox plate for most of its time. But yeah, it's a pretty close call, and I unfortunately there's no CAD model to look at it. There's no fully modeled and constrained piston for me to see if this collides with. Again, that's just a product of how the team works. Like, nothing that can be changed at my home sitting in front of my computer. We're mostly done. I'm gonna do like one final thing. We just measure the weight of everything. So I've given weights to everything, like things that are aluminum 661 or aluminum 661, and things that are aluminum 7075 or aluminum 7075. So we come out to a final of 3.43 pounds. So that was the weight of the whole gearbox before I took out. Yeah, so that 3.45 pounds, that was about the weight of the gearbox without any bolts or spacers or shafts, with the plate unlightened. So after lightening out the holes and then re-adding and putting in all the shafts and everything on the bolts, we've come out to around the same weight. So 3.5 pounds. I would say so 7 pounds in total for 2 gearboxes, compared to 9 pounds for the 2 ball shifters. And the two ball shifters, because we added so much extra stuff on top, I think it probably came out to close to 9.5, maybe 10 pounds. So I think in total we save at least 2 pounds. We've saved 2 pounds, and I think really 3 pounds across the board. And more than saving 3 pounds, I think we've saved a lot of space in between the gearboxes. And the biggest fixes is that it's more structurally rigid, and it's like worlds easier. Like, it's incredibly easy to service now, and I think that's something that we should be proud of, because um, yeah, it was really hard. It was really hard to work with them before. And I think I have no idea if we're ever gonna make this plate, but I filmed this 6-part video series to kind of show how to do this, and to like kind of at every single step enforce the same design reasoning, and help you guys understand, like, this plate is something that we could really easily machine. We operate out of like a fully tooled machine shop, and making a small plate like this, you upload the drawing of it, and you sort of just tell your machine, hey, this generate G code for this, and then do it. And we're very privileged and we're very lucky to have that. I think in 2Train's history, we definitely kind of have avoided these complex plate designs and relied on IndyMart kit bot chassis gearboxes or some ball shifters. But designing a plate like this and figuring out and constraining out all the motors, it isn't like a Herculean task. I'm not gonna say I'm very good at it. This is like one of the first this is actually the first custom West Coast drive gearbox I've ever designed. But just working off like your knowledge of how motors mount, and how gear ratios work, and center distances, and general manufacturing know-how for FRC, you can like design a nice looking, I think nice looking gearbox design really quickly. So I guess the spiel is that you can, with some effort and some thinking and some research, you can design a really big improvement to our robot, without needing to be with the robot, or without needing to be with the robot or having tools on hand. And that's the power of CAD, and speaks to how much this coronavirus sucks. I'm doing this and not working on the robot. But it's allowed for this opportunity. So that's basically it. If you guys have any questions, let me know in the Slack. I'd be very impressed if you managed to make it all the way through to this final part. Considering like 3 hours of it are just me struggling in Onshape. I'm not gonna head out now because there's a bonus part. That if you like really manage to stick around, you're gonna see even more CAD. But that's basically it for now. This is a West Coast Drive single speed gearbox geared for around 14 feet per second theoretical speed, free speed, and designed to make 30-foot sprints from the loading zone to the trench, as well as the loading zone to the target zone. In summary, the main changes were rigidity to reduce vibration and gearbox loosening, as well as motor accessibility. And we've done both of those things where the motors are completely loose, like able to be loosened from just external looking at the drivetrain without needing to move any wheels. And by adding a whole plate for surface area contact instead of just 4 long spacers, we have this whole plate that screws onto the gearbox and then to the tubing. We've generated a lot more rigidity in the whole structure. So those are our 2 main objectives, and I think we have achieved them. Weight savings wasn't like a super big consideration here, but we did ultimately end up saving a lot of weight. And if you wanted to save even more weight, we could not chop down this other half, not being used, and you save some amount of weight again. So yeah, these 2 gearboxes weigh 7 pounds compared to our old gearboxes, which weigh in total 9.5, almost 10 pounds. And yeah, there's significant weight savings and there's significant packaging space saved. Before there was 4.2 inches in between the motors, now there's 7. Here there used to be 7 inches, now there are 13 inches in between. So basically a bunch of weight, space, time saved with these plates. If anyone has any critique of how I designed them, again, please let me know. Comments, Slack, whatever. Yeah, that's that. Thanks for watching.